Hello, this is question 1 on your mechanics paper from Edexcel November 2020. So you have at time t0, small ball is projected vertically upwards with speed u from a point that is 16.8 meters above horizontal ground. The speed of the ball at the instant immediately before it hits the ground is 90 meters per second, and the ball hits the ground after t seconds. Motion of the ball is modeled as a particle moving freely under gravity, and the acceleration is going to be 10 instead of 9.8. Be careful because it's quite common to keep using 9.8 because we are used to it. Using the model, we have to find u, also that is 5. So what we have really is a particle that is starting from a point above the ground, it's going up and then it's going down. And if this is the ground, we have that the height, the initial height is 16.8 meters, So this is what we are going to write here, 16.8 meters. And the initial velocity is u, but we don't know, so vertical initial velocity. And we know the velocity here is 19. The velocity here is down. The particle is going down, so the velocity is down. And this is 19 meters per second. And the velocity here is up. So the velocity is up to here, 0 here, and then down. To find the velocity, what we are going to do is to write SUVAT. And I'm going to decide a positive direction. Let's say this is positive is up. So I know information about the whole thing. So I can write the whole thing, So the displacement from here to here is minus 16.8. Minus 16.8 is down. Initial velocity is what I need to find. Final velocity is going to be minus 19 because it's down. The acceleration is 10, but it's going to be negative again because the acceleration is the gravity, and the gravity is always down. It doesn't matter how the particle is moving, that's going to be always down. We need one equation without t because we don't have t and we are not interested in finding it yet. So that equation without t is this one. V squared is u squared plus 2as. You have the list of SUVAT equations in your formula booklet, So v squared is minus 19 squared is u squared is what I need to find, plus 2 times a times s, so minus 10, kind of squeezing it, minus 10 and minus 16.8. From here you have that u squared is 25, which means that u is 5 meters per second. We are going to get the positive one, So that's the first part. Then for b, we need to find the time. So we are going to use the same thing, but now we need an equation with t. And it doesn't matter which one we use. So we can use the simplest one, which I think is v is u plus 80. V is minus 19, u is 5, and the acceleration is gravity, so minus 10. I'm going to use the same numbers that I'm using here, And from here, t is going to be minus 19 minus 5, which is minus 24 divided by minus 10, 2.4 seconds. And that's the total time of flight, So from here to here. Then find the time from the instant the ball is projected until it is 1.2 meters below A. So this point was A. We didn't write it, but this is A. This is 16.8, and they are asking me the time where the particle is just 1.2 meters below A. So the particle is going to go up, then down until 1.2 meters below A. So let's say that that point is. So this is 1.2 meters. So we don't know now the final velocity, for example. Let's going to see what we know. So let's going to write SUVAT for that part. So if we write SUVAT again, and again we consider this positive, displacement is going to be minus 1.2. So I am 1.2 meters below it was at the beginning. Initial velocity is 5 and it's positive because it's up, and I say up is positive. We don't know the final velocity. Acceleration again is -10, and time is what we need. So we are going to use one SUVAT equation. We have V, which is this one. S is ut plus 1/2 at squared. Substitute everything I know. 5t minus, because acceleration is negative, 1/2 times 10 times t squared. And from here, I have a quadratic. I'm going to solve it. I have two values of t. One is positive, one is negative. So I'm going to pick the positive one. And this is 1.2 seconds. Yeah? And then it's a sketch a velocity time graph for the motion of the ball between 0 and t seconds, stating the coordinates of the start point and the end point of your graph. So we are going to have something like this. If we represent velocity in the vertical axis, so in meters per second, and say I'm going to do it higher. Time in the horizontal axis, seconds. Initial velocity was 5, positive, and the final velocity is 19. Yeah, remember, final velocity is 19, but it's negative because it's in the opposite direction. So positive and negative velocity, it just means that it has changed direction, nothing else. Yeah, and that happens when t is 2.4 seconds, right? So my final point, my final velocity is when t is 2.4 seconds, my velocity is -19. That's my final point, that's my initial point. Acceleration is constant because it's the gravity, which means I'm going to have a straight line joining both points, yeah? So if I have constant acceleration, my gradient of my line, the gradient of the line is going to be constant. It's going to be a straight line. So this is my graph, which means the particle is starting with positive velocity 5, decreasing the velocity, stopping at the top, and then increasing the velocity but in the other direction. So this point is when the particle is at the top. So it's decreasing the velocity, stopping, and then accelerating but in the other direction. So accelerating but in negative numbers. Yeah, you see the absolute value is increasing but in negative values, which means just the other direction. Then in a refinement of the model of the motion of the ball, the effect of air resistance on the ball is included, and this refined model is now used to find the value of u. State with a reason if this value of u will be how it will be compared with the initial one. So this question is tricky, and there is an examiner report talking about this question because this keeps coming out and everyone makes the same mistake. Because you think if you are going to include now the air resistance, the velocity will be slower, so the ball will move slower because it has to overcome an air resistance that I wasn't considering before. But what is happening is we still have to find u for the same condition. So the particle must arrive to the ground with velocity -19 or velocity 19, which means if I consider the air resistance, I have to project this with more velocity. Yeah, I have to kick the ball stronger to make it arrive to the ground with the same velocity. Yeah, so if I want to overcome the air resistance, so this velocity must be greater, not smaller. They are asking me about this one, not about this one. Yeah, this one. So u must be greater, and u must be greater. And I know it's a bit confusing. It must be greater, so it overcomes the air resistance and reaches the ground at the same speed. Suggest one further refinement that could be made to the model apart from including air resistance that could make the model more realistic. I would say every time you have gravity, you can say the same, more accurate value of gravity. Yeah, value of G. And that's always a mark, and that's easy and something that you can remember. Yeah, and that's all with this exam question.